Morning, everyone. Myself, Monica Das, Assistant Professor, Department of Pharmaceutical Chemistry, School of Pharmacy, the New India University. So, we have got a very interesting topic, that is radiopharmaceutical from pharmaceutical inorganic chemistry, that is of first semester, first year from B Pharm. So, to understand this topic, first we have to understand what is isotope. So, we have to come across the term isotope. What is this isotope? Every atom has electron, proton, and neutron. So, as an example, I have given carbon. Carbon has its own atomic number that is present in periodic number, that is 12. So, this 12 number of atom, 6 is neutron and 6 is proton. So this is divided into 6 ratio. So what happens when there is an excess amount of proton when comes across in this atom, there is a tendency of emitting this electron to become stable. So from there, this concept of isotope has come. When there is an excess amount of proton in the atom, this is called isotope. So isotopes are variant of particular chemical element which differ in neutron number and consequently in nucleon number. All isotope of a given atom or an element have the same number of proton but different number of neutron in each atom. So the number of proton remains the same but the number of neutron changes. So isotope of an element are the atom of same element and the same atomic number Z but different mass number. They occupy the same place in the periodic table and have similar chemical property. So what happened? There is an emission of this neutron and proton. So this emission is called radioactive decay. What is radioactive decay? Is also known as nuclear decay or radioactivity. This radioactive in disintegration or nuclear disintegration is the process by which an unstable atom nucleus loses energy by radiations. This excess amount of energy is lost by the radiation. So what happened? This radiation is used as an application in this pharmaceutical industry. So what happened? A material containing unstable nuclei is considered radioactive. Three of the most common type of decay are alpha decay, beta decay, and gamma decay. So the radiation that is emitting is categorized into three parts, that is alpha, beta, and gamma. All these which involves emitting one or more particle. Next, there is a type of decay, that is alpha and beta gamma radiation. This decay which are used in pharmaceutical industry and various purposes, further it is used. So what happens in alpha ray, which could barely penetrate a piece of paper, beta ray which could penetrate 3 mm of aluminium, and gamma ray which could penetrate several centimeters of lead. We now know that alpha rays are helium nuclei, beta rays are neutron electrons, and gamma rays are electromagnetic radiation. So accordingly, they work in their respective field. Now, how to measure, or what is the unit? What is the unit of radioactivity? The old unit of radioactivity was Curie, named after the scientist, that is Madame Marie Curie and Pierre Curie, the pioneer which studied the phenomenon of radioactivity. One Curie is the number of disintegration emanating from 1 gram of radium 226 and is equal to 3.7 into 1010 BQ. So in the international system, the unit of radioactivity is 1 nuclear transmutation per second and is expressed in becquerel, named after the scientist Henry Becquerel. So the main as unit of radioactivity is Curie. So there is a measurement of radioactivity. What happens in the radioactivity? We have to understand how much amount of radiation or radiation is been emitted or what type of radiation is been emitting from a isotope or a compound. So to measure this, the measurement of nuclear radiation and the detection is an important aspect in the identification of type of radiation. So we have to understand what type of radiation is being emitted from the different type of isotopes and how much amount. So to assay this, the radionuclide emitting the radiation, a suitable detectors had been made or identified for this purpose. So the detectors are, what is the application of these detectors? The detectors are used to detect the suitable type of radiations. The radiations are identified on the basis of their property. Next, so what type of radiation, what type of instruments are used in this uh, radioactivity? There is an ionization effect is measured in ionization chamber, proportional counter and Geiger-Müller counter is used in this purpose. So what happens in measuring, another is important measurement instrument is that is stellenation effect of radiation is measured using stellenation detector, and photographic effect is measured by the autoradiography. So here the Geiger-Müller counter plays an important role in the identification of the radiation. So I have come made a account in this topic to be very much clear about the Geiger-Müller counter because it is the most important instrument in this subject. So the Geiger-Müller counter was developed by Geiger-Müller and Müller in German in the year 1928. This device was used to detect and measure the measuring ionization radiation. This was used with all type of radiation, that is alpha, beta, and gamma easily. So through this instrument, we were used to detect all the types of radiation. The oldest radiation detector used to low cost simplicity. So, what is the principle that revolves around is the Geiger-Müller counter consists of a GM tube sensitizing element which detects the radiation and a processing electronics which displays the result. The GM tube is filled with an inert gas with a helium, neon, and argon at a low pressure with which the high voltage is applied. The tube conducts electrical charge and a particle or photon of incident radiation makes the gas conducted by radiations. The ionization considerably amplified within the tube to produce easily measured detection pulse which is fed to processing electronic and display the result. So this is the whole setup of the Geiger-Müller counter apparatus where the source of the isotope is immersed in this chamber and all the particles, that is positive and negative particles, get scattered in this area. So the negative part of the electrode gets in the aluminum tube, that is, and the positive goes to the electrode and the helium or the that are neutral get attracts with the gamma ray. So the negative that is attracted is the alpha, the positive is the beta, and the neutral that gets attached with the is the gamma ray. So according to charge of this, here the impulse is created. So what happens? This radiopharmaceuticals are used. What is the application of this Geiger-Müller counter in this pharmaceutical purposes? So what happens? So, what is the application? It is help in both diagnosis and therapy. So, pharmaceuticals are used for both diagnosis, meaning the imaging the function of organs and tissue, and therapy, delivering targeted radiation to destroy the diseased cell. So, what happened? According to alpha, beta, gamma, according to the penetration power, they both are all these are used in diagnosis and therapy. It can also be used in therapy like delivering and destroying disease cells like cancer cells, that is very much widely used in medical conditions. So, in diagnostic application, cancer detecting and staging, cardiovascular assessment, neurological studies, these all are the applications where diagnostic where the therapeutic applications are made. Diagnosis, and in therapeutic, thyroid gland disorder, cancer treatment, these all are the application where prostate cancer cells, these all are the cells that are destroyed by the radiation, as the gamma ray can penetrate the whole infection. So these are all the applications where the radiopharmaceutical compounds are used. In this, radiation plays a very important role in pharmaceutical uh, companies or pharmaceutical subject. Next, it is very important as this contains very harmful rays like alpha, beta, gamma. Long term in use may cause very harmful. So, handling and storage of this radioactive material is much more important rather than also doing work. So, what happens in handling? Great care must be taken in handling and storage of radioactive material, so as to protect the people from its harmful effect. The radioactive material are stored in remote area such that it should be away from exposure to human being. Alpha and beta emitter are stored in thick glass such that shielding effect is provided, while gamma emitters are stored in lead container. The area of radioactive material should be tested more intensity for radioactivity. Exposure to radioactive radiation can cause blood cancer to the person. So it's very much important to handle the radioactive material. The person who are handling must be very careful about this. Lead shielding is required while handling with radioactive substances. So, shielding effect can also be achieved by water layer and concrete blocks. Water layer blocks only radiation which allow visible light to pass, while concrete block also or blocks all the radiation. So this was all the storage and handling of radioactive material. There are much more points we have to be come through, and the handling should be very much important about this before doing any experiment or any radiation is emitted in this pharmaceutical radiation. Thank you.